Hello everyone. I hope you are all safe and well despite of our a lot of things happened during our the opening of class. I hope you can cope up to our last two lessons or last three lessons of this subject, the basic education, science and chemistry. For my topic, I will be the one to discuss about the ionic bonds and its structures, formulas, and properties. This lesson is anchored to the K-12 basic education curriculum, senior high school, science, technology, engineering, and mathematics specialized subject, general chemistry 1. The content standard is the learner demonstrate on understanding of the ionic bond formation in terms of atomic properties and in relation and the properties of ionic compounds in relations to their structure. For the learning competencies, draw Lewis structures of ions, predict the formula of ionic compound formed by metal and nonmetal among the representative elements, list the properties of ionic compound and explain these properties in terms of its structure. What is a Lewis structure? It is also called a electron dot structure or electron dot diagrams are diagrams that show the bonding between atoms of a molecule and the lone pairs of electrons that may exist in molecule. Lewis structures show each atom in the structure of the molecule using its chemical symbol. Lines are drawn between atoms that are bonded to one another. Rarely, pairs of dots and are used instead of lines. Excess electrons that form lone pairs are represented as pair of dots and are placed next to the atoms in which they reside. The Lewis structure the Lewis structure for an individual atom is drawn by placing a dot around the atom for each valence electron available. There are 4 positions available for dots to be placed. Most chemists draw them on the top, left, bottom, and right of the atom. So as you can see on the image. So this is an example of the Lewis dot symbol per element. We have the hydrogen, lithium, magnesium, and so on and so forth. So the Lewis dot symbols are placed in top, left, right, or in bottom. So the number of valence electrons are counted based on the uh, last orbital or last electrons placed on their uh, respective orbitals. So we have here for the hydrogen 1, magnesium 2, for carbon 4, nitrogen 5, and so on and so forth. So let's proceed to a concept or the topic of octet rule. Octet rule refers to the tendency of atom to prefer to have eight electrons in the valence shell. When atoms have fewer than 8 electrons, so they tend to react and form more stable compounds. When discussing the octet rule, we do not consider d or f electrons. Only the s and the p electrons are involved in the octet rule, making it useful for the main group elements not in the transition metal or inner transition metal blocks. An octet in these atoms corresponds to an electron configurations ending with the s2 and p6, or the s block and the p block. Now let's proceed to the structure of ionic bond. Lewis structures of ionic bond rather. Consider a sodium atoms in the presence of the chlorine atom. The two atoms have these Lewis electron diagrams and electron configuration. For the sodium atom to obtain an octet, it must lose an electron. An element that loses electron is what we call a positively charged or cation. And for the chlorine atom to gain an octet, it must gain an electron. An element that gain electron is what we call the anion. An electron transfer from the sodium atom to the chlorine atom will uh, occur, or will, yeah, the sodium will give off the sodium will give off its valence electron, one valence electron to chlorine to uh, form or to comply the octet rule. So both species now have complete octets, and the electron shells are energetically stable. So we know that the opposite from the physics, applying the physics concepts of physics, we know that these opposite charges attract, and this is what happens to the sodium and chlorine. The sodium becomes a positively charged and the chlorine becomes a negatively charged. The sodium becomes a cations and a chlorine becomes an anions. Uh, so what happens? Then we have written the final formula for the sodium chloride, or the NaCl. The attraction between the oppositely charged ions is called an ionic bond, and it is one of the main types of chemical bonds in chemistry. Ionic bonds are caused by the electrons transferring from one atom to another. So, example of this is the sodium and the chlorine, where the sodium give up its electrons to chlorine to form an octet. And the same with the chlorine. Chlorine gained or received these electrons from the sodium. So another example is the magnesium and the oxygen atom. So in electron transfer, the number of electrons lost must equal to the number of electrons gained. So we saw this in the transformation of the sodium chloride. And a similar process occurs also between this magnesium and oxygen, forming a magnesium oxide. Magnesium has a positive charge of 2 and oxygen has a negative charge of 2. And remember, in the formula for the ionic compound, we do not write the charges on the ions. Later, you will know how to predict a chemical formula of this ionic bond using the charges. So let's take another example of synthesis of calcium chloride. A calcium atom has a two valence electrons, while the chlorine atom has 7 electrons. A chlorine atom needs only one more to complete this octet, while the calcium atoms have 2 electrons to lose. Thus, we need two chlorine atoms to accept the 2 electrons from one calcium atom. So the transfer process looks like as follows, as you can see. The opposite charge ions attract each other to make a CaCl2, or what we call the calcium chloride. The other one, what about when a sodium atom interacts with an oxygen atom? So the oxygen atom still does not have an octet of electrons. What we need is a second sodium atom to donate a second electron to the oxygen atom. So these 3 ions attract each other to give an overall neutral charge ionic compound, which we write as Na2O, or sodium oxide. The need for the number of electrons lost being equal to the number of electrons gained explains why ionic compounds have the ratio of cations to anions that they do. This is required with the law of conservation of matter as well. That is why we need to add 2 sodiums to make complete the octet for the oxygen. Chemical formula of ionic bonds or ionic compound. So this topic I referred to the report of Miss Lorraine Jean D. Mantilla. So credits to you, Miss Lorraine. To write the chemical formula of compounds, write the symbol of uh, cation first, followed by the anion. How do we know that these elements are cations or anion? Later, there are a periodic table provided for you to identify those elements. Next, write their respective charges. We will have to look up to the periodic table to look on their charges. So when you write the formula for an anionic compound, remember that the positive ion is always listed first. Again, positive ions is also always listed first. So now let's find the lithium and the oxygen since yun yung example natin. So based on the common ionic states of the elements, we should look at the locations of the elements on the periodic table. So atoms in the same columns as each other group tends to exhibit similar characteristics, including the number of electrons and the elements would need to gain or lose to resemble the nearest noble gas atom. To determine the common ionic compounds formed by element, you keep the you must keep or reminded that group 1 the group 1 ions or the alkali metals have positive 1 charges. Group 2 ions or the alkaline earth metals have positive 2 charges, and the group 6 ions or the nonmetals have negative 2 charges, and for the group 7 or the halides have positive 1 charges or negative 1 charges rather. So there is no simple way to predict the charges of the transition metals. So you must look at a table listing the charges or the valences for possible values, and for the introductory of the general chemistry, positive 1, positive 2, and positive 3 charges are the most often used. Now we'll have the chemical formula of the ionic bond compound. So as we identify the charges of each element, put them together using the crisscross method. And this crisscross method is done by writing the charge value of the first ion as a subscript of the second ion and vice versa. So you drop the positive and negative signs. So as you can see on the image, you don't need you drop the signs and you don't need to write the one there on the oxygen, and that's it. The two will we must write or copy the 2 in a subscript of the lithium, and that's it. We have a lithium oxide. So same is done with the following compounds. So first you must look these elements with which of it is the positive ions, identify their charges, and then you use the crisscross method, drop the signs. You don't need to write the 1 there on the magnesium and you copy the 2 and drop off the signs. The same with the calcium fluoride. To predict the formulas of ionic compounds from the following elements, we have here an example of exercises. Let's predict the formula of the lithium and oxygen, which is already given, nickel and sulfur, bismuth and fluorine, and the magnesium and chlorine. So following the methods or the processes in predicting the formula, first is you identify the elements, which is the positive and the negative ions, identify their charges as you already identified their charges, you apply the crisscross method, And here it is. A lithium has a positive 1 charge and oxygen has a negative 2 charge. Therefore, there must be a 2 lithium ions are required to balance a 1 oxygen ions. So the answer is lithium oxide. Nickel has a charge of positive 2 and sulfur has a negative 2 charge. Therefore, there must be 1 nickel ion required to balance the the sulfur ion. So we have the nickel sulfide. Bismuth has a 3 positive 3 charge and fluorine has a negative 1 charge. Therefore, there must be 1 bismuth ion required to balance the fluorine. And number 1 is the magnesium has a positive 2 charge and chlorine has a negative 1 charge, and therefore magnesium ion is required to balance a chlorine ions, forming a magnesium chloride. That's it. First is to identify their ions, whether they are positive and negative, know their charges, crisscross, and then you can identify you can predict their formula. And for the properties of ionic bond, so number 1 is very hard and brittle. They are very hard and brittle because the ionic crystals are hard because the positive and the negative ions are strongly attracted to each other and difficult to separate. However, when pressure is applied to an ionic crystal, then ions of like charge may be forced closer to each other. So the electronic repulsion can be enough to split the crystal, which is why ionic solids also a brittle. They have very high melting points and boiling points. High temperatures are required to overcome the attraction between the positive and negative ions in a ionic compound. Therefore, a lot of energy is required to melt ionic compound or cause them to boil. Another one is the very distinct three-dimensional crystal shapes. So they form crystals. Ionic compounds from crystal lattices rather than amorphous solids. So although molecular compounds form crystals, they frequently take other forms, plus the molecular crystals typically are softer than the ionic crystals. So at atomic levels, an ionic crystal is regular structure with cations and anion alternating with each other and forming a three-dimensional structure based largely on the smaller ion, evenly filling in the gap between the large ion. Next is they conduct electricity. They conduct electricity when they are dissolved in water. So when ionic compounds are dissolved in water, the dissociated ions are free to conduct electric charge through the solution. And the last one, they are a good insulators. Although they conduct in a molten form or in a aqueous solution, ionic solids do not conduct electricity very well because the ions are bound so tightly to each other. So those are the properties of a ionic bond. I hope you have learned something to my topic. And for any clarifications and questions, please email or message me. And that would be all. And for my references, these are my references. Thank you for listening and watching. Goodbye.